Welcome back to our series on multipolar agents and the promise of modeling emergence from the bottom up. Last time we discussed limitations of traditional agent models and the need for more generative foundations. Today we're excited to dive into introducing multipolar agents themselves, flexible building blocks enabling intrinsic evolution, learning, and complexity. We'll tour the tripole architecture that serves as their core engine of complexity. Think of the triple or tripole as the DNA of multipolar agents. As biologist Erwin Schrödinger observed in his book What is Life, living organisms seem to defy entropy by locally concentrating order and exporting disorder to their environment. Multipolar agents achieve this metabolism-like phenomenon through the tripole. The name comes from its three components linked into a functional circuit. Sensory components take in environmental signals. Actuators export configured outputs, while mediators modulate the tripole's internal polarity bias between order and disorder. By closing the loop from perception to action modulated by internal states, even this simple structure displays properties of autonomy, adaptation, and self-directed behavior. Connecting triples together forms neural network-like pathways that afford sensation, thought, and action across the agent's body. And by hierarchically composing tripoles into larger metatripoles, vast bodies of complexity can emerge from the interactions of individual building blocks. So while sounding obscure at first, this tripole scheme offers a profoundly powerful innovation in agent modeling, one that finally puts open-ended complexity within practical reach. Everything multipolar agents become arises from recursive tripole composition rather than top-down engineering. Let's take a closer look at the sensory component to tripoles. Sensory modalities equip agents to observe their surroundings across various spectra. Common examples include vision, auditory perception, temperature sensitivity, or chemical reception. Critically, sensors are tuned to detect signature outputs that match the emissions they would produce when in an actuator mode. The sensors and actuators form harmonious pairs. Visual receptors are attracted to the same frequencies of light that eyes emit. Chemical sensors bind with molecules that the agent releases. This circular matching between a tripole sensing and actuating creates a self-reinforcing feedback. Agents sporting a particular actuator modality will gather where the corresponding sensors capture matching environmental signatures, like attracts like. Tuning sensor detection profiles to align with an actuator's effects spectrum enables tripoles to close the loop from perception to action. From a cybernetic perspective, this establishes circular causality, allowing functional control. The environment perceives the actuator modification and returns signals parsed by the tailored sensor. So while a single sensory modality lets an agent observe just a narrow band, combining multiple triples grants holistic situational awareness. Building up diverse sensory repertoires through specialized detectors offers multifaceted channels for world interaction. Let's look next at how agents can internally manipulate those perceptual signals using mediator components. If sensors feed external signals inward and actuators export configured manipulations outward, what connects the two? Enter the mediator components of triples. While sensors and actuators link agents to their environments, mediators modulate internal polarity states. Mediators control where on the order-disorder spectrum the triple's overall bias sits. This regulates whether the tripole tends to move up gradients towards energy sources and structure down gradients towards entropy sinks and decay. By adapting mediator polarities over time, agents alter their own inborn behavior preferences. Maybe early experiences cause an agent to develop an affinity for thermal energy, carefully regulating its internal temperature. Another agent might have mediators tuned towards dissolved nutrients, becoming attracted to food sources. Seeing this capacity for tripoles to tune sensitivities through mediating their polarity bias essentially acts as an adaptive preference learning mechanism. Findings accentuate sensory modalities that brought reward in the past, fading channels less attuned to opportunity content. Rather rigid, unchanging programs Mediator plasticity allows agents to update orientations. Joining us next as we continue examining Tripoles are the effector components, actuating outward-facing behavior based on internal drive states. Stay tuned. We've explored how sensors take in environmental signals and mediators manipulate internal states. Now let's look at the final component of tripoles, the actuators that complete the perception, cognition, action loop. If sensors are the ears and eyes and mediators the brain, actuators are the hands and mouths, effector components that enable world interaction. Example modalities include limbs for locomotion, grabbers for manipulation, speakers for communication, and reproducers for replication. Actuators translate internal energy stores into signature outputs, like motion, light, or sound, that emit into the environment. Critically, as discussed earlier, actuator emission spectra align with the tuned sensitivities of their paired sensory component. This couples action and perception. Actuators export high entropy configurations powered by internal energy locally, but this discharged energy often contains information, structure, or utility from the agent's internal state. When communicative signaling or reproductive self-copying, actuator outputs crystallize internal order into environmental change. By choosing from diverse specialized actuators compiled into a repertoire, Tripoles gain adaptability in how they modify surroundings. Beyond emitting raw energy, appropriately configured actuators allow structured modification attuned to particular goals, environments, or tasks. Now let's examine how connecting match sensors, mediators, and actuators establishes closed functional loops, enabling autonomous behavior. So we've talked about the three parts of a triple: sensors detecting what's going on externally, mediators managing internal states, actuators making changes out in the world. These connect together into a closed circuit, almost like a control loop. The sensors spot something happening around the agent, blasted input triggers or suppresses the mediator portions, regulating how the agent feels internally. Then, depending on that mediated internal state, the actuators might kick into gear, generating some reaction back out into the environment. This completes a full cycle, action to perception and back again. By closing this loop, even a single triple exhibits a primitive form of autonomy. It acts based on what it senses, while what it enacts then feeds back to tune its sensory channels. We also talked about aligning the tuned frequencies of sensors to match the emission properties of their paired actuators. So as an actuator generates effects rippling through the environment, the corresponding sensor is literally built to detect those same signals. This links action and perception tightly together. Connecting multiple triples allows more complex back and forth cycles between agent and world. Stacked triples passing signals around recursive loops enable richer behaviors. It establishes feedback circuits that ultimately drive the emergence of cognition and complexity, as we'll continue exploring. So far we've mostly talked about individual triples, but you can also link up groups of triples into larger structures in some neat ways. The simplest is just forming a chain. Triple A connects to triple B, which connects to triple C, and so on. This creates a sequence where signals pass along sensor at mediator actuator for each unit in order. But more interesting is composing triples into hierarchies. Here the triples all interconnect with two-way connections, so it can influence B, which can also loop back to affect A. There are recursive feedback loops. This lets signals diffuse across the network, getting transformed as different triple modifiers. It becomes a collective processing structure rather than rigid linear step. Emergent group-level behaviors can arise from these hierarchies that no individual triple exhibits on its own. The cooperative organization adapts dynamically based on which triples assume what roles as signals propagate. It's kind of like the transition from individual cells to multicellular life. Cells can coordinate their signaling, differentiation, and development into an integrated organism far more capable than any solo cell. Similarly, hierarchical triple arrangements give rise to bodies of immense complexity from the interactions of simple components. This potential for recursive composition is what offers such scalability and flexibility compared to traditional rigid agent architecture. Let's continue next time by checking out some models of triple swarms in simulated environments exhibiting cool collective behaviors. Now that we've covered the basics of the triple architecture and how they enable rich composition into agents, we're ready to see these building blocks in action. Join us next episode as we create example simulations placing swarms of multipolar agents into dynamic environments and observe the emerging results. These are keen, even starting from simple initial conditions. The self-organizing properties quickly lead to structure and coordination. We'll see illustrations of phenomena like flocking and schooling behaviors, foraging for resources, evolution of communication, social group formation, construction through stigmergy, and examine how these outcomes arise decentralized from agent interactions rather than any pre-programmed behaviors. Understanding how local rules scale into global order is key as we attempt to engineer systems capable of open-ended complexity from the ground up through generative models like multipolar agents. This balances order and chaos through a phase transition, enabling lifelike adaptivity. By embracing radical bottom-up emergence over human scripting of design, multipolar agents offer a revolutionary paradigm for creating worlds bustling with creativity rather than constraint. Join us next time as we explore how minimal ingredients blend into rich decentralized organization.